Got some sounds. Well, good evening, everybody. Welcome. Say hi in the chat. I've got an agenda, as always. And so there's some things that I want to at least attempt, and some things that I've already prepared. And we'll get into those shortly. First of all, yeah. Hey, Zelen Mo, thanks for joining. Awesome. I don't recognize your name, so it's good to see you. Tell me a little bit about what brings you here. That would be awesome. Because it's a very small number of people turn up for these things, and you never know. So, what was my agenda? There was something I was going to print. Can I remember what it was? No, not at all. Let me ramble. Actually, no, let me just check that everything is okay on the terminal, on this one terminal, and then we'll switch to the other one. Because I need to go get a drink to prepare myself. So, that's a great way to start. Let's start with the first. For some reason that I still don't understand, the very, very first serial character that it detects is always wrong. So I get a ZWD instead of a PWD. But anyway. Yeah, there's nothing much new in the repo. There's a bunch of stuff in a different repo, but that's a different story. Yeah, the TTY test thing. I was gonna try the TTY tests basically all through this to test various pieces of functionality. And the best way to look at these is to use the dash list, except my E letter is busted on this keyboard. There's a whole set of tests that are in this little Python script. And last time we did the carriage return test and failed on my work in progress teletype. And that's what we're going to fix with a kernel patch today. And then the right margin test, we can't succeed on this because of hardware. And the space test, I should be able to succeed in as well. Line feed test is going to be interesting. Prints a slash, and then does a line feed, and then does another one. And it should just like literally do a diagonal. And then lines of characters. So if I do TTY test 4, and let's see what that looks like. It prints a line of ABC. So TTY test 4 is very sensible. Types lines of characters ABC, and so and so and so and so and so forth. And then at the end, it says 33 is types 6 lines of the worst case pattern. And this is worst case because it has to spin the print head completely round from one side to the other to print. So if there's any misalignment or if there's any gunk in the works, the worst case pattern is going to fail. So I'm going to try this one and then see what happens. So let's do TTY test 33 on the machine. And that is the worst case pattern. Apparently that's as bad as it gets. So back in 1 second while that's making some noise. So that teletype passes with flying colors the worst case pattern test. It prints all the way up to the final end where it ends up overstriking because it hit the right carriage, but that's actually fine. It prints very clearly lines of the worst case pattern. Zellin Mo, I love learning about computing, especially Unix and command lines. That's what brings me here. Awesome. Would love to have a similar setup someday. Yes. Well, these are these are fascinating machines. Yes. Good. Well, so hang out and have fun. Today we're going to get into Unix in a way that I've never gotten into Unix before. So that's the purpose of this. So we're going to spin away from this very nicely tuned, working great teletype machine across to the repair bench where I have my not working very great teletype machine. Let's see, zoom out a little. I actually want to straighten this thing, but I guess I can. I've been messing with tripods, situations and stuff. Zoom in a little. Yeah, there's the test machine and it's in all its not very straight on the bench glory. You can't read this very well, and that's a pity because we're going to want to read this. So I'll get closer and zoom in when we get to it. But this machine in progress, there's a couple things. I mean, first of all, it's not very well run in, so I don't know if there are sticky things that would completely fail that worst case test. I totally expect there are, that it just wouldn't work. And in fact, we had some even worse situations where it was just printing okay for 5 minutes and then completely went haywire. But assuming that it's more or less printing okay, there was a problem that we hit last time that is all about the software. It's not about the hardware. And the problem looks like this. So TTY test 0, if I go back into my TTY test 0, it says, checks the ability of carriage return to print at position 1 from all of the other print positions. No printing should occur in any position other than position 1. So that's great. And then we have a nice printout on paper. When it does this, Basically, it's spaced across and then hit carriage return and hit position 1. But then each time down here it spaces further. So by the time it's spacing all the way across here and hits carriage return and then prints a letter X, it hasn't gotten all the way back to here before the X hits the paper. So carriage return from here to here literally is the time for the carriage to flip back and go whoomp, and that's about 1/3 of a second, certainly more than 1/4 of a second. And it's not a hardware problem. It's like there's a spring. I actually have a brand new carriage return spring in here. The old one was decomposed with age and mice. So I have a brand new spring, new old stock. I know that it's working okay because you let go and it springs back. But you can't beat the physics. Right? It's never going to spring back fast enough to do this. And so what you do is you go to your Unix terminal, and in your Unix terminal, we'll do it on the actual teletype, but in this like terminal, you can say STTY, and actually let's look at the manual, because in the manual there is a set of things here about delays. And backspace delay, we don't, there is no backspace. We're not even going to get there. So there's no point talking about backspace delay because it physically doesn't have a backspace capability. Carriage return delay, though, we would want this. We want to have the operating system put in a delay after every carriage return. And we also want to have a form feed. Actually, we don't have a form feed. We have a new line. There's no form feed on this, like new page doesn't really exist. But we want to have a new line delay as well, so that there's enough time for the platen to actually turn if you hit new line. So I want to say CR3, get the most delay, and NL1, get a little bit of delay. And this is a Raspberry Pi. Oops. This is a Raspberry Pi running Linux, and it's running the latest Buster Debian 10 based Linux, and it doesn't implement new line delay. And let me show you the actual code, because I had to go look it up. So here we are on the Raspbian source code up on GitHub, and under drivers there's a load of drivers, as you'd expect with a Raspberry Pi, but one of them is TTY, which means the teletype. Actually, the terminal, it's like that name is because Linux terminals are named after the teletype. And there's a file in here which is the line discipline. This is the kind of the default Linux terminal line discipline. So that means it's the thing that's responsible for editing in a line, and it's also the thing that handles. So, for example, you can hit Control whatever to kill the line. You can hit Control V to insert a literal something or other. If I say echo, oops, in the right window, echo, and then I hit Control V and then return, then it means print a literal return. And that's implemented in the line discipline. So there's quite a lot of functionality actually in the line discipline. And let's go search for CRDLA. And we have a nice little paragraph that tells us what Linux does with carriage return delay. It says Linux ignores tab delay and character return delay, and vertical tab, that's the form feed. Vertical tab and form feed, separate things, and new line delay, they simply aren't relevant in the world today. If you ever need them, add them here. Challenge accepted. So there you are. That's what we're going to do in the kernel. And I already kind of built that code, and I think I've tested it on just like Linux, but I haven't tested it on a machine. So that's the goal today, is to plug in the line delays. So I got some reading. I got this in the mail. I meant to order it a little while ago when it first came out. It's pretty recent. And it arrived yesterday, and I read like the first chapter, and it's wonderful. Brian Kernighan, the guy that wrote Kernighan Ritchie, KNR, the C programming language. This is his memoir. There's a nice picture of him on the back. It's a really easy read. It's like, this guy can write. I mean, I guess the C language would not have been as wildly popular if it didn't have a really good tech writer writing a really good book about how to use it. And I think the same with Unix in general, that it wouldn't have been the operating system that took over the world without having Brian Kernighan not just writing actual software tools, but also writing documentation on it. Anyway, this is his memoir, so it's really good. But this is also like there's a glitch in the history, right, between like the Bell Labs derived Unixes and Linux. Like, you won't find this comment in the original Unix. Linux was written from scratch, pretty much. Was written, and the kernel was written in the early 90s, when teletypes were already obsolete. So, like, there was no real need. They simply aren't relevant in the world today. It was probably true, actually. I think this was originally written by Linus, and then most of it was written by Theodore Tso and various patches from other people. So what I did was I went in here and forked this thing and went into where are we? Drivers, TTY, ntty.c, which is the line discipline, and I added experimental support for the Teletype ASR33 terminal. And I added a little comment saying experimental implementation of the three things that we care about. And so the three things that I think we care about are a carriage return delay, so that when I hit carriage return, it has time to go here. And then new line delay, so that when we do a new line, there's a little delay there as well. And also X case. And X case is basically X case says escape the uppercase characters with a backslash in front of them. So if I'm in like Mac OS, Darwin, BSD derived, Unix derived, STTY, X case, and it actually doesn't have it. It still has the bits inside of term iOS, but it doesn't. STTY doesn't have it anymore. They took it out. It used to be there in BSD, I think. I don't have a BSD copy running, but I assume that FreeBSD and NetBSD and so on still have this option. Lcase, if it was implemented, is basically, well, let's have a look at the manual on here. If I click the right window, it would help. Lcase, Lcase uppercase is the same as Lcase lowercase. That's kind of funny. Now, Lcase is Xcase, IUCLC, OLCUC. And so this means, so this is the STTY command. And so the way to think of this, STTY is just a little application that really doesn't do anything except set flags in the current device, whatever that terminal device is. And there's a set of flags called term iOS that STTY sets. It can read and set them, that's all it does. It doesn't have any actual logic of how to process characters at all. STTY is just like this thing that says, go set this flag in the terminal iOS thing in the device, whatever device you point it at, right? So if I'm here and I say STTY, then it shows me whatever my settings are, and I can say STTY, let's not do UTF-8 input. And basically that didn't do anything at all except clear a flag in this term iOS structure that controls the terminal device that's talking about UTF-8. Hey, Code Squirrel, I'll do SU. SU too. Welcome. Absolutely. So yeah, you can set your own device, right? STTY, IUTF-8. Let's flip that bit back on. And then tell it which device to go set that on, because the term iOS structure is attached to the even better. Term iOS structure is attached to the device, so I can oh sorry, I have to say -F to say which terminal am I setting on. So anyway, back to the manual. L case is the same as X case, and that means escape uppercase letters with a backslash in front of them when you print them and on the input as well. IUCLC means if you have an input that's an uppercase character, turn it lowercase. And then OLCUC says if you have an output of a lowercase character, turn it uppercase. So this is what you need to support a teletype. But X case, not only is it not implemented at all on Darwin, but it's also not implemented on Linux. And I wonder if it says that. Does it say it? Nah. It just says escape for But let's look in term iOS instead. Yeah, it says not in POSIX, not supported under Linux, but I'm going to have to edit this man page because I've created a patch that supports it. It says, if iCanon is also set, the terminal is uppercase only. Inputs converted to lowercase, which is this IUCLC thing, and uppercase on output. So, let's show you where this is. Yeah, there's this comment at the beginning of the thing. I also edited this comment in here. It used to say Linux ignores tab delay, CR delay, and VT delay, and FF delay, and NL delay, and I took out the ones that are relevant in today's world. But yeah, there's a set of changes in here that implement X case, and here's one of the examples. It says, if the terminal is in X case mode, then if it's an uppercase character, then output a slash in front of it. And so there's a bunch of little changes through the file. You can look in this repo, and there is only one commit, which is all of these changes. So it adds support for X case, and it adds support for outputting a new line delay and a carriage return delay. So the way that it does a carriage return delay, there's actually two ways in Unix that carriage return delays are supported, as far as I know. As I say, not having BSD, and I didn't look at like old Unix source for this, but per my understanding, there's two ways to support character return delays, and one is to let's go. Yeah, let's look at this to show you. In the manual, there's a fill mode that says send fill characters after a character return. Send some fill characters so that effectively there's a delay. And then the other is without this set, it uses a timer. And then you can choose the fill character to be a null or a rub out. Not implemented on Linux, except now it is. Now, the timer thing seemed problematic to me because I don't know, like, I'm sending a delay, I'm sending a carriage return, but I don't know if there's any buffers in the hardware that if I like send a carriage return and then delay 300 milliseconds and then send the next character, I don't know if that 300 milliseconds is going to get eaten up in buffers. So also I didn't know, like, if I'm in the middle of the kernel, like doing stuff, and I just like hold a delay, like what's the right way to do that in a safe Linux kernel way? The kernel has constraints and I don't know what they are. So I only implemented the ofill version of this. So you can set ofill and then it'll put 2 or 3 or 1 or 2 or 3 nulls or del characters for a new line or a character return delay. So anyway, there's all my changes. Now, I'm going to narrate, and maybe I should show like the process of go building these changes, right? So let's switch back to a terminal window. Here's my build. I have a separate build user account on the Raspberry Pi, and this is the Raspberry Pi, and I have a Linux directory, and it is hopefully up to date with nothing stray running around. It's on this Teletype branch that is connected to the repo that we looked at earlier. So basically all you've got to do is check out this branch from the repo here. And then there's a couple things you've got to do to build. You've got to do this, and then you've got to do the install process. And the install process, then you've got to reboot because you've just installed the kernel. So this is a complete rebuild of Linux, except it's incremental. Like I built it already. There's nothing actually new to do. I built this already. It only takes, like the full build, I think took like a half hour. This is a Pi 4. It's a pretty beefy machine. So yeah, even doing like a full build of Linux you don't need to wait overnight for the thing to come back again. Those instructions, by the way, come from the Raspberry Pi How to Build Linux web page. It's like completely trivial, well documented. Building the kernel web page, and it says what you need to install to make it work, and then you git clone this thing, except git clone my one if you want the patch, and then you build it. And you can build it on a different machine if you want, on a non-Raspberry Pi, non-Linux. Well, you have to build it on Linux, but you can cross-compile from any machine because the compiler doesn't really care what architecture it's targeting. Yeah, and then you end up with a brand new shiny copy of Linux with my lovely patches. And so I actually did this already. I built it and I installed it and I rebooted the Raspberry Pi. So this is like not really necessary. But I didn't turn it on. So That's what we have to do now. So, okay, I'm going to do some of this testing actually on the nice teletype, because the X-case piece, I think, is better done on here than... Separate thing, please. Yeah, the X-case piece, we should try that and see if it actually works nice. Just from here. I mean, I can show you it from the SSH terminal, but that's kind of boring because we have a real terminal. So let's do it on a real terminal. So first up, here's a set of stuff, right? And if I look at the equivalent on my actual terminal, then license is in uppercase and readme.md is in mixed case, and most of the other stuff is in lowercase. But I can't tell when I'm looking at this. And if I go in my regular terminal and I say edit a file, what case is this? I don't really know. Right, so there's that file, what? I can cat it on here, that's great. But if I go back on here, then I can't really tell. I don't know if it's uppercase or lowercase. So that's the whole point of the L case flag. And it appears to work. It does actually appear to work. It escapes with a backslash anything that's uppercase. So the word hello begins with a capital H. The word what begins with a capital W. And so on. So this is X-case on output. And this is in the kernel, which I'm well pleased about. I'm actually like totally amazed about, to be honest. And I mean, really, I thought I was going to be repairing hardware, and instead I'm like messing with Linux kernel code. Not like, that's not my day job. Nobody should trust me near kernel code, really. I think it's quite clean, the changes I've made, but I don't know for sure if I've broken anything. So it was a little kind of interesting when I was like going through the first time of like, let's recompile the kernel on this machine and install it. And is the whole thing, I mean, it turns out it's actually going to recompile the whole kernel, which is kind of stupid. When I install it, is it going to blow up like the whole terminal, make it completely unusable? And actually, I succeeded in not making it totally unusable. But now, that's only one half of X-case. And the other half of X-case is harder, which is the input side. So this is the side that I don't really know if it works or not. Actually, it kind of has some funny peculiarities. But let's go into the editor. Oh no. Oh yeah, I can go into the editor. I should be able to insert uppercase characters with the editor. Now that I'm in L case like mode, if I open this in ED, I should be able to insert some stuff in there. Let's try. Yes. So watch this very carefully, because this is a sign of the work is being done in the kernel. When you hit the backslash, it doesn't echo it. And then you hit the next letter and it echoes, because it's in L case, it echoes slash and then the letter. So the echo proves that it is an uppercase character as far as the kernel is concerned. At least that's my theory, and I'm sticking to it. I'm going to zoom out a little so you can see my keyboarding. Yeah. Hit this. No echo. Hit this. Okay, seems to be legit. Let's cat the file. Let's see if that editing session actually did the right thing. This is a first line, lowercase. It says it's uppercase, and the backslash, you just do a double backslash, so that's fine. Is it true? Well, we're going to go back here to a regular SSH session to find out. I mean, I could do hex dump or something. I could do OD to look at the bits, but let's just cat it on here. And sure enough, that there looks like, to me, whoops, that looks like a Teletype edited mixed case file, and that, I think, is the first time in history that Linux could do that. Now, does line wrapping properly account for the extra characters? Are you trying to trick me or something? There's no line wrap. I haven't figured line wrap out, actually. So this machine in the corner here, the main clean one, literally has no line wrap. If you type something that's too long, it'll just keep banging against the end of the line until you stop. There's no line wrap. I implemented a little piece of Arduino code to do line wrap at 80. Because this is not connected through the serial port directly. It's connected to a current loop to USB adapter that uses a Teensy microcontroller, and that is doing some case conversion and stuff already. And it's not doing these X case slashes, but it's taking everything to lowercase already. But anyway, so there's no line wrap. But then this works machine has word wrap, but it's mechanical, and I don't know where it is. Somehow, when you get to the end of the line here, I'm just going to keep pressing the G. And it has some glitches, which we'll fix in time. That's hardware glitches. But then when you get right to the end of the line, it has automatic character turn. So it has a hardware character return line feed. And it has a terrible timing glitch. It has a really terrible timing glitch, and I think I know exactly why. I might just get in there and fix it. Or at least get in there and adjust it. So yeah, this has hardware line feed automatic word wrap, but I don't know, like, where is there's a little detent somewhere that implements it, and I want to take it out because I don't want hardware line wrap. But anyway, yeah, let's come back to the adjustment in just a second. So that's X case, and X case on input, and X case on output, and there's one caveat, which is you need X case and L case, and you need the whole L case set. X case, I, UC, LC, I, UC, LC, UC, O, whatever those combinations were. X case. That's a little caveat, and there's another one. Oh yeah, don't use it with Unicode, because this is not a Unicode terminal, it's an ASCII terminal. It's the ASCII terminal. All right. Yeah, enough ramblings of that sort. That's the X case piece of this work. There are 3 pieces of this work. One of them is how to do X case, and the others are to do the carriage return delay and the new line delay. All right. Now, for this, I could not figure out how to test it. So this is completely untested work. I mean, on here, I can actually do STTY, L case, and get myself in the same situation, right? Here I am. Everything is uppercase now, right? If I do LS, then everything's escaped, and I can cat that file, and it looks just like it does on the teletype, right? So X case is actually relatively easy to test with just a SSH session. But carriage return delay is different. I don't know how to test it. I mean, the way to test it, the right way to test it, which I want to get to, is to use the this thing. Yeah, let me hold it there instead. To use the deck teletype test routines that do like a line of spaces and then hit return and then immediately print an X and see if the OS gives you enough time for the carriage return. But what it's doing in theory, if I show you back on here, STTY minus L case, turn that thing back off, STTY CR3 O-fill, because I don't want to use delays, I want to use fill characters. And then I can't see them, right? But then, of course, if I dump this through kind of the hex dump or something, I won't see them either, because they're not inserted in the middle of the pipeline. It's like, it's not inserting them in the output of LS and then through the pipe, right? I won't see nulls in this output. It's only after they go from the pipeline inside of the process in the shell to the physical terminal that the line discipline adds nulls. It's like, how do you capture that? I mean, maybe you can actually capture it by saying on a different terminal, go, I think, if I look at who's logged in, I'm on the PTS0. So if I can say cat dev PTS0 pipe through OD, and now I'll get a hex dump of everything that comes out here. Will I? I mean, I basically kind of broke my terminal. Do I get any nulls in here? I get OD, OD, but I can't really tell. It's like, because I've got two things that are outputting from this terminal, it's like, that doesn't really work. That's kind of broken. I get OD, OD, OD. I don't know if that... There's no nulls in there anyway. Like, I can't figure out how to test it. But luckily, testing things with the teletype itself is super easy. Because we have not just print, but we have punchtape. And the punchtape is a true record of the bytes that hit the terminal. It's doing some overprinty things. But this is a true record of each byte that hit the terminal, because it's mechanically connected to the printer. Now there's no nulls. Oh, there is some nulls in here. So I'm going to show you a carriage return and a line feed. I don't know what happened to that LS. Like, something is screwy with my terminal now. I might have to just like restart everything. Anyway, I don't know what's screwy. But here I'm going to show you a carriage return and a line feed. Let's put them up there. Where is it? So I say LS. The first thing with the three dots, that's a L. The next one is a S. Then there's a bunch of nulls. And then there's a carriage return, and then there's two nulls, and then there's a line feed, and then there's a null, and then I don't know what there is. Anyway, I think that's carriage return and the nulls and line feed. That's being done by the teensy in Arduino firmware. So my machine is lying about what it's receiving from the OS because it's not got a raw connection. It's got a Arduino special connection. Now, that's why I have this machine. Because this machine, my connection goes RS-232, current loop to RS-232 using this little adapter. Swing this back around. Unlock it. Close enough to be useful. Alright, that will do for now. So this little thing is the RS-232 straightly output from the back of the machine. And then this goes into the Raspberry Pi GPIO port, where there's zero shenanigans. And then when I turn this thing on, I've got some hardware shenanigans, but there's zero software shenanigans. There's nothing in between the GPIO port and here that's got any intelligence to it at all. It's just literally a couple of transistors for a current loop to serial to RS-232, and then a couple level shifters on the GPIO port so that RS-232 doesn't break the Raspberry Pi GPIO. So if I'm in my terminal window here and I see that the user named test is auto logined because of the way that I've got Getty set up here, and I can go here. Actually, let's do it from here. Echo ABC, dev ttyama0. Let's look at who's logged in. It is ttyama0. And I can't just like randomly send things to a random device without owning the device. But here I see the words ABC, and ABC did actually print. And you can't really see it very well. So let's see there. Then hopefully you can see. It's a little bit bright, I know, because of the lighting here. Is that an improvement? Maybe. Reduces the contrast. It's nice and bright. Okay, so yeah, I can print characters to this thing. Let's go on here. Dev ttyama0. I'm going to set those terminal settings to lcase CR3NL1. Three nulls after a character return, one null. Oh, fill. iCanon, because you have to have that for anything to work. Fill, so that it uses fill characters. And okay. So we've got all of these settings: Xcase, uppercase to lowercase conversion, NL1, CR3. So now if I say, let's resize this a little. How about like that? No, not like that. How about like that? That's better. Because now if I say echo ABC DEF GHI to the device, then hopefully my Xcase stuff will kick in. I mean, I'm not convinced that it will, but let's try. Yes! Okay. And in theory, it had 2 carriage return delays and a new line delay, right? So if I say echo new line, I want printf if I'm going to do like that. Okay, yes. New line. Okay. So I'm printing a little bit of mixed case stuff, and then a carriage return, and then a couple letters, and then another carriage return. Now, this thing does also have, because it's an ASR, and you can't quite see it, so let's shrink this even further and move that out of the way a little bit. There, so you can see the tape punch. This this lovely thing here is going to punch some paper tape with whatever. It's mechanically connected to the printer, so any bytes that hit the printer are going to come out on tape. Could also do echo-E. What is echo-E? I don't know what echo-E is. Oh. Okay. I don't. I don't know what echo-E actually does. It lets you enter escape sequences. Oh, cool. Oh, yeah. Okay. Instead of printf. Gotcha. Gotcha, thank you. Yeah, I'm just learning this stuff. So what I need to test my kernel patch is some paper tape. And how many kernel patches can you say that for? And who the hell thought we were going to do kernel patches anyway? I think this needs blue paper tape. This is the joy of this, right? I mean, I'm doing C code in a Linux kernel. That's not really my specialty. And the only way to test it that I can think of is with paper tape. There has to be a more modern way, I just don't know it. So how much tape are we going to need? I've just tore off a bit. Because without the cover on, you can't really, you can't load tape very easily. So let's turn this on. Oh yeah. I'm gonna have to fix this thing because it's gonna get brutal now. All right. I am gonna fix this with a screwdriver. If I could only find. Oh no, I'll fix it with a hex thing. There is a thing called the rangefinder on here, and I'm just gonna change my rangefinder setting while it's on, which is a little dodgy. Yeah, I don't know. Let's see if that makes any difference. It may not. But the rangefinder basically adjusts when it starts the new byte for a read for something that's going to go to the printer. That's it. Yeah, I didn't fix it. Oh well. Let's feed some tape. Feed tape all the way through. Yes. Okay. There is tape coming out the end of this thing. Let's print this thing to the terminal. Oh, I'm on local. Let's try that again. Oh, crappity creep. Okay. I have to pull my punch tape. It's not, there's some gunk in here somewhere that means my punch tape is not coming through. I have to keep pulling it. So there's actually a decent amount of hardware maintenance still to do on this unit. So let's try that again. Okay. Stop! I don't know why it went completely skewy. Let's try it again. No. Poor thing. No. Okay. We got halfway there. And I have a result that I want to show. And I'm gonna show it up on here, but I've turned this thing off. So this is the yellow tape that I punched on the other machine. And you remember I started by saying LS, and then I hit return, and there's a few nulls in here, and there's a carriage return. So I said ls, and then there's a few nulls. These nulls are put in by the teensy microcontroller, but there's a carriage return, null null, line feed, and then a null, and then some more stuff. Oh, the more stuff is the ls getting echoed back, maybe? No. There's ls twice. Anyway, that is what a carriage return line feed looks like. So here on the blue tape, there's some stuff that didn't really print properly. And then we have a whole set of output characters that go basically ABC, \D, \E, \F, GHI, carriage return, null, 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 3 nulls, line feed, and then another null, and then in fact a whole tape of nulls because the null broke something in the timing. And then this is all like garbage stuff because my receive hardware is misaligned. And I think it's got to be the rangefinder. At least that's the first place to start. Yeah, I'm gonna have to like think and then look at hardware and stuff. But this paper tape proves that at least the CR part of my fix in the kernel is inserting nulls after a carriage return. And I know what I can do to even change that. I can say STTY of this device, OFDEL, that fills the output with del characters instead of null characters. And let's get some more tape and go try it. So, another 10 feet of tape. And I'm going to have to cut this into a nice little V to make it fit through the machine. And feed it in here. And see if I can get it to feed through. Yep, there it goes. And turn it on. Okay, calm down. What about that? It stopped. It doesn't stop. It doesn't really stop. So I don't think it's my rangefinder. I think it's something else. Does CR3? No, it adds 3 nulls. Explicitly 3 nulls. Yeah. And CR2 adds 2 nulls. And CR1 adds 1 null. And yeah, here's the piece of new code that does that. It says how many characters to insert, and it's going to insert either nulls or it's going to insert the rub out character. So what I think I've done here is to say OFDEL sets it to use the rub out character. So let's roll this. Turn on the tape punch. Hit this. Nope. No, my timing is all messed up. It is not printing right at all. It's printing garbage. If I can get it to print something that resembles normality. But it's not. Nothing so lucky. I've got a very screwy printer here. I can see something that looks like a del character, and a whole series of them, but it's interspersed amongst all of this garbage, so I can't really be sure. But if anyone has like a good way of actually testing like the CR fills, I literally don't know how to do it. I mean, within an SSH terminal, because you want to capture the raw bytes that the line discipline put out to the terminal. So yeah, it's like I'm stuck between hardware that doesn't work and software that I think now the software works. So I think now the software works. What I want to do next, of course, is go TTY test and run the carriage return test, TTY test 0. But my printer is not reliable enough to do that yet. But last time it kind of was. I mean, this is a very intermittent kind of status. And this is what happened with the TTY test 0. It prints a line of spaces and then hits carriage return, and the X should line up in this column here because we've got enough nulls now for it to delay before it hits the end. But with my printer in this state, I don't think I can reliably do it. And I could test on the other machine, but the other machine has a teensy microcontroller like in the way. This has like just wires in the way, like there's no logic. There is a magical way actually that might work to test with the other machine. I can put the teensy into pass-through mode. So I think I'll do that. Yeah, totally. I can put the teensy into pass-through mode. Yeah, let's see. There is a thing somewhere, and I can't remember exactly what it is. In here, there is a shell script. Oh no, it's not a shell script. It's an alias. Is it? Somewhere I have a thing that says, yeah. There it is. T-binary. So the teensy is controlled by some escape sequences, which are kind of like ANSI escape sequences. So the teensy has a bit of logic, and this thing sets it into binary mode. At least I think it does. So let's try it. It does. Now, as you can see, pure binary mode doesn't even have carriage return and line feed. It's getting a line feed. Sorry, it's getting a line feed, but not a carriage return from Unix. Yeah, that's kind of interesting. Why is it Why is it not doing actual carriage returns? This is now a raw connection. STTY-F device TTY ACM0. This is the teensy. And it has that. It's got that. Okay. Now in the home of the test user that this machine's logged into, there's a .profile that does, I think, all the right things. So I can just log this thing in as test. This the real one. I can just log it in as test and see what happens. I don't have carriage returns, and I still don't know why I don't have carriage returns. Paper looks like it might have a few years on it. It does. Yeah, this is definitely old stock paper, of which I have a reasonable amount. And it's a lovely color, but I should really switch to using like new paper for tests, because you can still get new paper. You can like order it online and they're still making it. Then I won't use my stock of old stuff. Yeah. So what? There's a carriage return. ONL OCRNL, no. I want ONLCR, which is this one here. Translate new line to carriage return new line on output. Okay. Let's have a look at the full version of that. ONLC. It has it set already. I don't know why it's like squishing them. I'm just going to ignore that for now. I'm just going to type some stuff, have it echo, and see if I've got some nulls. And actually, I'm going to go further than that. I'm going to set the OFDEL as well. So I can just cat that watch file, I think. making this far too complicated. I think it must be like late at night or something. Let's become the test user. I'm going to turn off that L case because I want like a regular thing. I'm going to use ED because I can. Let's put some new text in here. ABC, return. DEF, return. What else do I want? That's it. Yep. No, even easier than that. CR test. Let's make a shell script, and it's going to say ABC echo DEF. Okay, STTY OF del GHI HJK. Okay. All right. ABC, DEF, something weird happened because my OFDEL is messing with my terminal. But let's try it on here. This makes sense. I think I'm maybe losing it, but this is going to print some letters in a new line, and then it's going to switch the output fill character to the del, which is like all ones, and then it's going to print some more new lines. Seems legit. Right here. 10/20th. Okay, and did it work? It didn't really work. It didn't work. I mean, how am I going to test new lines? I'm not seeing any new lines, any character returns. I'm seeing new lines. And my new lines are not coming out as nulls on here, or as zeros, or as anything. It's like, it's incomprehensible. It's like a, yeah, I have a failed test. Pah! Okay. I can't think straight anyway. Can you hear the noise? The noise in the background, by the way, is our local roller derby that is in the next building, or in the next kind of place to the brickyard here. Have some hearts. Eric, these are your hearts. I'm going to call it a day. Let me recap. The Linux here has a thing here that says Xcase is not supported under Linux. Well, it is now. And it also has this thing in the Linux sources that says Linux ignores CR delay and NL delay and other things as well. And not anymore, it doesn't. It now implements. I left this saying it still ignores tab delay, VT delay, FF delay. If you want to install this version of Linux that has these patches, then go build it yourself. It's really easy. Just go to, just cloned this repo. I forget what the default branch is. I think it's a branch called Teletype. Clone this repo and then follow the instructions on the kernel building Raspberry Pi page. It should actually apply to any version of Linux. It doesn't have to be a Raspbian Linux. Yeah, I mean you can build this on anything, but it's Linux. There's also in here, in my ASR33 repo, under rpi, I put a directory called Kernel, and the kernel directory has basically the full file and a patch file and description, so you can just like go there and that'll get you all the way there. And it seems to work. I think this is your fault, Eric, actually. Wasn't it you? I mean, when I was like talking about like my failure to do this thing, you said we need a Teletype distro. Well, kind of we have. I'm going to run with it. I'm going to leave another trail of half-finished software behind me. But we now have a version of Linux specifically handling Xcase. And Xcase is a beautiful thing. Xcase escapes, it would if you could see them. It escapes your uppercase characters, and it does it on input and on output, so you can actually edit mixed case files. I could now write an entire real document in any language, and I mean anything ASCII, right? ASCII 63 is a hardware limitation. But yeah, the kernel on Linux now supports Xcase, and I'm very pleased about that. And it supports carriage return delay, although we'll have to wait until this is mechanically in a better place before I can run the TTY test thing to actually prove it. So there we are. I think that's it for the evening. I hope you're having as much fun watching this as I am doing this. It's seriously so much fun. So thanks for hanging out. Seriously, yeah. Go buy a copy of Brian's book on Amazon or wherever he sells it, because so far I've only got through like the first chapter, but his writing, it's like falling off a log. I mean, somehow he manages to just like write things that are beautifully easy to read and humorous and lovely, just lovely. So yeah, it is 1:30 a.m. Jake. It's 8:30 in the evening here. So thanks for watching. All right, take care, everybody. I'll check in again sometime soon. No idea when. Have fun.